Hey everyone, Admin Chief here. Today, we're going to embark on an exciting journey into the world of systems programming, a field that's evolving rapidly and bringing new opportunities for developers everywhere. And today, we're diving into the world of Rust, a programming language that's been making waves in the tech industry. Rust isn't just another language, it's a revolution in how we think about building software. You might be wondering, what's all the hype about? Why is everyone talking about Rust? Well, it's because Rust addresses some of the most critical issues in software development today. Well, Rust is changing the game when it comes to building fast, reliable, and secure software. It's designed to help developers create applications that are not only efficient, but also robust and secure. Created by Mozilla, the same folks behind the Firefox browser, Rust was designed to tackle the challenges of modern software development. Mozilla's goal was to create a language that could handle the demands of today's complex systems while ensuring safety and performance. It's a systems programming language, meaning it's used to build the core components of operating systems, web browsers, and other essential software. This makes Rust incredibly versatile and powerful. But unlike its predecessors, Rust brings a fresh perspective to the table. It combines the low-level control of languages like C and C++ with modern features that make development more accessible and less error-prone. Rust is all about empowering developers to write code that's not only lightning fast, but also incredibly safe and reliable. It does this by enforcing strict rules that prevent common programming errors. It achieves this through its innovative approach to memory management and concurrency, two aspects of programming that have traditionally been prone to errors. Rust's ownership system ensures that memory is managed safely, preventing issues like null pointer dereferencing and buffer overflows. With Rust, you can say goodbye to those dreaded segmentation faults and race conditions that keep you up at night. The language's design helps you catch errors at compile time long before they can cause problems in production. So, whether you're a seasoned programmer or just starting your coding journey, Rust is definitely worth checking out. Its growing community and extensive documentation make it easier than ever to get started. In the following sections, we'll explore the key features that make Rust so special and why it's poised to become a dominant force in the future of software development. We'll look at real-world examples, hear from developers who have made the switch, and see how Rust is being used to build the next generation of software. Stay tuned, and let's dive deeper into the world of Rust. At its core, Rust is built on three fundamental principles: safety, speed, and concurrency. These principles are not just buzzwords, they are the foundation upon which Rust is designed and developed. They guide every aspect of the language, from its syntax to its compiler, and they are what make Rust stand out in the crowded landscape of programming languages. These principles are deeply ingrained in the language's design and are key to understanding what makes Rust so unique. When you start coding in Rust, you immediately notice how these principles influence your workflow and the quality of your code. They are not just theoretical concepts, but practical tools that help you write better, more efficient, and more reliable software. Let's break down each principle and see how it translates into real-world benefits. Understanding these principles will not only make you a better Rust programmer, but also give you insights into why Rust is gaining so much traction in the software development community. First and foremost, Rust is obsessed with safety. Safety in Rust is not an afterthought, it is a primary concern. The language is designed to catch errors at compile time, long before your code ever runs. This proactive approach to error handling can save you countless hours of debugging and troubleshooting. It's like having a super-powered compiler that acts as your coding buddy, constantly looking over your shoulder and catching potential errors before they turn into major headaches. This compiler is not just a tool, it's a mentor that helps you write better code by enforcing strict rules and guidelines. Rust's strict type system and ownership model ensure that your code is memory safe, meaning you won't encounter those dreaded segmentation faults that plague other languages like C and C++. Memory safety is crucial for building reliable software, and Rust achieves this without sacrificing performance. But safety doesn't come at the cost of speed. Rust is designed to be both safe and fast, a combination that is often hard to achieve. The language's performance characteristics are comparable to those of C and C++, making it suitable for a wide range of applications, from system programming to web development. Rust is blazing fast, often rivaling the performance of C and C++. This speed is not just theoretical, it is backed by numerous benchmarks and real-world applications. Developers who switch to Rust often report significant performance improvements in their projects. This is because Rust compiles directly to native code, meaning it can run directly on your hardware without any bulky interpreters or virtual machines. This direct compilation process ensures that your code runs as efficiently as possible, making the most of your hardware's capabilities. It's like having a Formula One race car at your disposal, ready to zoom through your code at lightning speed. This speed advantage can be a game changer, especially in performance-critical applications where every millisecond counts. Finally, Rust embraces concurrency, the ability to execute multiple tasks simultaneously. Concurrency is becoming increasingly important in modern software development, as applications need to handle more tasks in parallel to take full advantage of multi-core processes. In today's multi-core world, concurrency is essential for building high-performance applications. Rust's concurrency model is designed to be both powerful and easy to use, allowing you to write concurrent code without the usual pitfalls and complexities. Rust's ownership model and borrow checker work together to ensure that concurrent code is not only fast, but also free from data races and other concurrency bugs. This combination of safety and performance makes Rust an ideal choice for building robust, high-performance applications that can scale with the demands of modern computing. One of Rust's standout features is its unwavering commitment to memory safety. This is a fundamental aspect that sets Rust apart from many other programming languages. Think of it as a built-in bodyguard for your code, preventing those nasty memory-related errors that can crash your programs and lead to security vulnerabilities. These errors, such as null pointer dereferencing, buffer overflows, and use after free bugs, are notorious for causing unpredictable behavior and security risks. So, how does Rust achieve this? The secret lies in its innovative ownership system. This system is designed to manage memory in a way that is both efficient and safe, ensuring that your code runs smoothly without unexpected crashes. In Rust, every piece of data has a single owner at any given time. This ownership model is central to Rust's memory management strategy. It's like having a designated driver for your data, ensuring it's always handled responsibly. Just as a designated driver ensures everyone gets home safely, Rust's ownership system ensures that data is managed correctly, preventing issues like data races and memory corruption. When the owner goes out of scope, the data is automatically deallocated, preventing memory leaks and dangling pointers. This automatic deallocation is akin to a recycling system for memory, ensuring that resources are efficiently reused without manual intervention. But what about sharing data between different parts of your program? Rust has you covered with its borrowing system. This system allows for safe and controlled access to data across different parts of your code base. You can lend out your data to other parts of your code, but with strict rules in place. These rules ensure that while data is being borrowed, it cannot be modified in ways that would lead to inconsistencies or errors. It's like lending your car to a friend. You set clear boundaries to ensure they handle it with care and return it in good condition. Similarly, Rust's borrowing rules ensure that borrowed data is treated with the same level of care and respect. This combination of ownership and borrowing might sound restrictive at first, but it's the key to Rust's memory safety guarantees. These guarantees provide a solid foundation for building reliable and secure software. The compiler acts as a strict enforcer, ensuring that all the rules are followed. It meticulously checks your code for potential violations of the ownership and borrowing rules, catching errors early in the development process. It's like having a superpowered code reviewer that never sleeps, catching potential errors before they even have a chance to compile. This proactive approach to error detection helps developers write safer and more reliable code, reducing the likelihood of bugs and security vulnerabilities in production. By embracing Rust's unique approach to memory safety, developers can focus more on building features and less on debugging elusive memory errors. This leads to more robust applications and a smoother development experience overall. In summary, Rust's ownership and borrowing systems, enforced by its vigilant compiler, provide a powerful framework for writing safe and efficient code. This unique approach not only eliminates common memory errors, but also empowers developers to create high-performance applications with confidence. Concurrency, the art of making your program do multiple things at once, is notoriously tricky to get right. It's like juggling chainsaws while riding a unicycle. One wrong move and your program can come crashing down in a heap of errors. But fear not, because Rust is here to make concurrency less daunting. Rust's ownership and borrowing system, which we explored earlier, plays a crucial role in ensuring thread safety. Remember that designated driver analogy? It applies here too. By strictly controlling how data is accessed and modified by different threads, Rust prevents data races and other concurrency bugs that can lead to unpredictable behavior. Rust also provides high-level abstractions like channels and mutexes, which make it easier to write concurrent code without shooting yourself in the foot. These abstractions provide safe and convenient ways for threads to communicate with each other and synchronize their access to shared resources. The result? You can write concurrent code with confidence, knowing that Rust has your back. It's like having a team of expert jugglers and unicycle riders at your disposal, ready to handle the complexities of concurrency with grace and precision.